So how is all of this concept applied on a project? It's 3 steps. The first step is you define the goals for a stage. So you define what you want to accomplish in the stage that you're starting to work in. The second is the second piece of the first step is to select goal matching primitives from that set of 23 primitives that we looked at earlier. So which of the primitives can accomplish the goals that you just identified? Then after defining the primitives, you look at the guidelines that you've defined for the primitives and create your BIM elements in a warehouse model. And also by looking at the primitives, you define the cost assemblies in the warehouse reference. Either define that from scratch, as mentioned earlier, or copy it from an earlier project or a standard data source. In step 2, so during each stage, you first determine the differences with the previous stage. If you use this approach, the previous stage will have had a model warehouse and a cost reference as well, so it's very easy to determine where the differences are. The cost differences you can easily find by using the Vico Office compare and update functionality, which highlights where in your project the differences are, and you simply update your project with the differences. As for the model, you just look at the warehouse and might want to use some of the modeling application scheduling functions to see what the differences are. Then you create or update your project's BIM with the predefined elements. And of course, you may find elements that are not included in the warehouse. Maybe there is a part of the design for which you did not predefine an element yet. Those elements need to be logged so that there is no surprise as soon as you get to the end of the stage and there's no cost and schedule information for those elements. Also, during step 2, you copy the cost assemblies from the stage reference into your current project. You copy the tasks from the reference into your current project. And of course, there's continuous checking to see if everything is being built as specified in the primitives that you selected for that stage. In step 3, so after each stage, everything is linked together and you check the model and data with the primitives. And because you have documented what is expected for each of the building element categories, you know which primitive objects you picked, you can rate the quality of each of the aspects in the data set. So you can rate what the quality of the model is. Were the penetrations really included or were they not, and was that expected or not? And provide feedback to the team so that either corrections can be made or there is or you can start an improvement process for the next stage, which leads to the last action item in this step, which is planning the next stage by, again, determining what the goals are for that stage, picking the level of detail and primitives that would be needed. So let's take a look at an example as the last part of today's session. The first step is to define the goals for this stage. And let's say that the goal is to calculate the overall cost for the project. And we also want to get a better understanding of the cost for the structural system. Then, in addition to that, we'd like to process the input from our structural engineer for the steel piece. And then we'd like to create a schedule at level 2. So that's going to be an S2 class schedule. So the first bit is to pick model primitives for level of detail 200. We'll look at the primitives that I will select in a moment. We'll use level of detail 300 model primitives for the structural steel because we want to use the exact profiles that the structural engineer provided us with. Then we'll build the model warehouse, and I will use Revit today to do that example. We will build or copy the cost data that was set up, and we'll end up by defining the task list. As for the model primitives that we're going to use, that's going to be solid wall at level of detail 200. So that's the basic diversification of material that we looked at earlier. Connections are not modeled, and for penetrations we will include the windows and doors only. For estimating, that's going to be the average cost per element, and for scheduling it's going to be average production rate per element. And the slabs that we'll include have the same diversification of materials. Another geometry guideline is that slopes and changes in slope are modeled within a plus or minus 5 degree tolerance. And for penetrations, only stair and elevator openings will be modeled. And for profiled steel, as I mentioned, we will go to the profiled column primitive, and we'll use the profile and type per the schedule that we received from the structural engineer. That means that it will be modeled from a geometry point of view with closely matching cross-sectional geometry. So some finer details like the exact rounding of the profile will not be included. That is only at level of detail 500 when it is needed for coordination purposes. For estimating purposes, that is not needed. So let's go into the Revit application, and we can take a look at the warehouse stage model that I put together. So here I've got my collection of elements, of steel elements, the profiled steel that I want to use. These are the slab elements, and here I got my basic walls as well as basic columns, structural columns. So all of these are generic, not exact size, an average size, and the naming follows that. So for the naming of these walls, we've got in the family type a generic name, cast in place reinforced concrete shaft wall. The ID part here at the end is to enable diversification later on, so we can put a number in there as soon as we're at that point. Elevator core walls, and here we got shear walls and reinforced and unreinforced CMU. So these names of the family types are going to be used later on to link our cost estimate to the model content. Let's take a look at the floor plan. So we've got that annotated so we know exactly what it is. Makes it easier to communicate it with the project team. So the way this works is you put this together before the stage starts, shared with the project team, and then when the project team starts to prepare the models, just copy and paste from here. So let's say I want to model with a cast-in-place reinforced concrete wall. I just use the clipboard to include that in my new project file. So this is an empty project file. I paste it in here, and I've got my elements set up. So at that point, I can start creating similar elements in the Revit application. And that works, of course, the same way in other modeling applications. You start you copy a basic element into the new project file and multiply that or edit the original element. So we've got some walls set up in here. Let me go back into the reference. I'm going to copy a slab on deck as well into my example. And I'm going to change the boundary a little bit, and it will include an opening. And as I select that, of course, you can see that the family type is exactly the same as in my warehouse. So that way I'm sure that the naming convention follows what I will expect when I work on my estimates. I can predefine formulas. Let's add a few more elements before we switch over to that. So I'm just going to include all of these members and switch over to the floor plan view and put them in here. And just to have a few more, I'll create a copy. Not the best structural design, but I'm sure it will work for what we want to accomplish today. So that is a model for a project that we created using the warehouse for this stage that we're currently working at. Now let's take a look at the cost piece I've put together in Vico Cost Planner by copying either from my standard reference or by creating assemblies from scratch, new cost assemblies. So what we see here to the left is the reference for the stage that I'm currently working on. So this is the reference for stage 3, as you can see. I've created a new project that's called Project Stage 3. All of that is in blue. And what I can do to populate my cost plan for this stage now is I can copy my line items from the reference into the current project. So I do that by just dragging and dropping. I can do that one by one, or I can bring in everything at once, and that gives me the framework for the estimate in this stage. When I select one of these walls or one of these assemblies, you can see that there is a formula over here at the top that has a name that matches the name that I gave my elements in the Revit model. So here we see B1012-025 cast in place reinforced concrete wall. When I go back into my Revit model, that is exactly the name that I gave it in the Revit model. When people work with these elements, they don't realize that they're actually already linking their model content to the cost estimate. So as soon as the model has been completed, we can publish it into Vico Office. So from the Revit application, there's the publisher in the external tools section. Excuse me. And we're going to publish this model into Project Stage 3, so that's what we just looked at. Create a new model, publish that, and as soon as that is completed, we have brought all the properties, so the family types that we defined, as well as the geometry, inside the Vico Office application. So when I go back to Vico Office, I can go to Manage Models, and I can activate my project stage model using the family type property that I decided to use, which could also be documented in the primitives, so my guidelines for each of the elements. And I click Activate, and I will see the model that I just prepared in Revit. Let me zoom out a little bit with the steel elements and the slab. And when I go into the takeoff model view, I will see all the takeoff names the takeoff items that are expected in the cost estimate. So these are the names that I wanted to use as variables in my formulas. For each of these takeoff items, we got our quantities now. So when I select one of these takeoff items, I can see the elements that are highlighted in the model. And I got my top surface area, my reference side surface area, opposite reference side surface areas, as well as volume. Same thing for the slab on deck. We got our top surface area and the bottom surface area and the volume as needed for cost estimating purposes. So just by publishing this model, copying my reference content from the estimating source into my current cost plan, I have built my stage cost plan using the model data that I wanted to use. So in here, in these line items, I now have, let me sort by quantity. We have the elements that are included in the model using the quantities. So we got the height quantity, which uses the height of those two columns. 2 times 10 feet equals 20 feet. And we can now define the cost of these elements by putting in the unit rates and calculate the cost for this project stage. When we're ready for this, we can also take a look at the scheduling piece. So in order to bring in the standards that we'd like for this stage, we just open up the standard task list and bring that in just by copying and pasting that into the task list in here, and it is ready to be linked for scheduling purposes. So these are the steps that we just went through. I created an empty project both in Revit and in Vico Office, and I copied the elements from the warehouse. I built a very simple model. I then copied the assemblies from the stage reference for the cost planning piece. I copied the tasks from the reference. I published the model and then activated, and we checked that all of the cost assemblies that had associated model elements in the Revit model were linked, and the quantities were already used in my project.